So if you have any doubt with the previous problems that we solved, you can message me in the Google Classroom, or you can even message in the YouTube link itself, so that we'll discuss the difficulties that you face. I hope most of you are clear with the problem that I solved in the previous class with respect to the frame structure. So this is another frame structure that I'm taking. So as you can see, this frame structure is built in by two columns and it is connected by a beam. Okay, so you need to observe the different types of joints we have, and also section and the length of the member. So let us go with one by one member. This is member AB, which is being subjected to horizontal load of 40 kilonewton, okay, which is at the center of the column. Next, this is the member BC, which is subjected to 60 kilonewton load at the center, and this is member CB, which is not subjected to any kind of force, right? So we know that the two column members are 2 times of I, and beam is simply I, right? So these are the physical aspects of this frame. Next thing is we'll try to observe the joints that we have. This joint A and D are fixed, but as you can see at joint C, it is having a pin joint. Okay, now the situation would have been completely different if I remove this pin joint. Okay, it would sway. Okay, right now all the frames that I am going to solve are non-sway frames. Okay, in yesterday problems or in the previous video, the problem that we solved was also a non-sway problem. Okay, the frame never used to sway. Okay, now if you try to observe this, if I remove this pin joint, okay, what this pin joint enables is a horizontal force here, right? So this horizontal force avoids the sway of this frame, right? So if I remove this horizontal reaction or this joint, this frame will sway because there is a horizontal force that has been applied here, and there are other conditions for which the sway will happen. I will discuss that later. Okay, anyhow, now this pin support here is avoiding the sway of the frame. Okay, so that you must be able to understand. So this structure is basically non-sway frame. Okay, when we go to sway frame, I'll be discussing all these different conditions in which frame will subjected to sway. Okay, now let us take this frame and we will disintegrate it, and we will try to understand what are the different reactions that are possible. Okay, so taking the joint A, joint D, so we know that there is a horizontal force. In the previous problem, while solving the previous problem, I had eliminated the horizontal reactions. Okay, I have overviewed that particular things. Okay, but while solving, by the end of the solution, we found that there is a horizontal reaction that gets generated, right? So in this you can observe that joint A and joint D are fixed joint, and because of their fixity there will be 3 reactions at joint A: VA, HA, which are vertical reaction, horizontal reaction, and MAB, which is movement reaction. Similarly at the D joint also there will be a vertical reaction, horizontal reaction, and movement reaction, right? So then I told you that there is one more reaction that is created at joint C because of this pin condition. So at this joint we have a reaction called HC. Okay, so this is the horizontal reaction which is additional at joint C. Now let us calculate the SI, which is static indeterminacy. Static indeterminacy is equals to sum of all the reactions, external reactions, minus of equilibrium equation. So in the previous video I had not considered the HA, what is that, horizontal reactions. So henceforth I had neglected one of the equilibrium equation. So in this case we would be including that equilibrium equation back, which is summation of horizontal reaction equals to 0. So that's why in the previous video it was 2, now it is 3. So 7 minus 3 is equals to 5. 5 is your static indeterminacy. Now going to kinematic indeterminacy. To resolve the kinematic indeterminacy, what we need to do is to look into the wholesome structure. Okay, so in this whole structure we know that this is fixed joint. At these fixed joint there cannot be translation or rotation. So theta A, theta D is equals to 0. Now this is an internal joint which is theta B. So theta B exists here because of the internal joint, it will undergo the rotation. Now going to theta C, this is not fixed condition. It means what, there is a rotation that will undergo, but it won't translate, right? So that's why delta C or delta is equals to 0, but theta C exists. So as you can see, this is my elastic curve. According to the elastic curve, I have shown you that theta B and theta C exists, right? So there is no delta value, or there are no other theta values. So the Ki, which is kinematic indeterminacy, is 2 degrees, and those two values are theta b and theta c. So we need to develop the slope deflection equation, and we need to solve the ei theta b and ei theta c terms. Okay, these are the two unknowns that we have. Okay, once you are done with solving the static indeterminacy and kinematic indeterminacy, what is the next thing we do is to observe each element with respect to their loading. We try to calculate how much is fixed end moments, right? So fixed end moments have been calculated here. This is MFAB, MFBA. As you know, MFAB and MFBA are equal in magnitude but opposite in sign. 40 into 4 divided by 8. So that will give you the value of MFAB and MFBA. Similarly for MFBC, this is your BC member, length is 3 meter. 60 into 3 divided by 8 will give you MFBC and MFCB. This is minus symbol, this is plus symbol. So once you calculate all the fixed end moments, next thing is to develop the slope deflection equation. So now let us solve the slope deflection equation for MAB. Similarly, we can solve for others also, right? So at MAB is equals to MFAB plus of 2 EI by L, 2 theta A plus theta B. We know theta A is equals to 0. Now let us substitute what is the I value here. I value for AB member is 2I. So this becomes 4 EI divided by length is 4, right? So theta A is cancelled out. So after simplifying, this is what I get for MAB, minus 20 plus of EI theta B. Now you try to develop this equation, MBA equation. So MBA is equals to MFBA. MFBA is 20, right? Plus of 2 EI theta B. Okay. So I hope this is very much clear, because we have solved numerous problems on this. You must be able to grasp this equations that we solve. Okay. Now going to MBC. MBC first term, which is MFBC, minus 22.5. MFBC is minus 22.5 plus of 2 EI by 3. Here I is equals to I itself. That's why 2 EI by 3 into bracket 2 theta B plus of theta C. After simplifying the equation, this is what I get. So I named it as third. Now similarly, MCB is equals to 22.5, which is MFCB plus of 2 EI theta B by 3 plus of 4 EI theta C by 3. This is my fourth equation. The last two equations are MCD and MDC. Now observe in MDC and MCE there is no external force. Because of that, there is no fixed end moment that are generated. So that's why it is equals to 0 plus of 4 EI by 4 into bracket 2 theta C plus of theta D. So simplifying this, 2 EI theta C. MCD is equal to 2 EI theta C. MDC will be equals to EI theta C. So these are your slope deflection equations. Now the next step is to determine the unknown values, which are EI theta B and EI theta C. So let us solve the equilibrium equation. So while solving the equilibrium equation, you need to identify where the kinematic indeterminacy exists. So we know that the kinematic indeterminacy exists at theta B and theta C. So we know that at this joint we can take the summation of moments at this joint is equals to 0. So it means what, MBA plus MBC will be equal to 0, and this will form my first equation. The next equation is MCB plus MCD will be my second equation, right? So what I have done is MBA, this is the MBA equation, this is the MBA equation which I substituted here. Then MBC equation I substituted and I simplified. This is my equation 1. Okay. Now similarly for MCB, so this is my equation for MCB, and this is the equation for MCD. So after simplifying, this is what equation I got. Using these two equations, I have determined how much is the value of EI theta B and EI theta C. Once I resolve these two values, I substitute these values back into the equation of slope deflection, and I will try to determine how much is MAB. MAB I have solved, which is minus 17.813. Similarly, MBA has been calculated, which is 24.374. In MBC and MCB, I substituted EI theta B and EI theta C value. I have calculated how much is the moments, minus 24.374 and 14.37 respectively. Similarly, MCD and MDC was equals to 2 times of EI theta C and EI theta C respectively. So according to that, I got the value of MCD and MDC values, right? So this is what the moments that we calculated for this particular frame. Now the next thing is to determine the reactions. Once we determine all the reactions that are created in this frame, we could be able to develop the shear force diagram and bending moment diagram. Okay, So I'll leave for you to solve the reactions for this frame. Okay, so once you solve it, and if you have any doubt, you can ask me. Okay, you try to solve the reactions, draw the shear force diagram and bending moment diagram for this frame. Okay, thank you.